So we continue the symmetric properties of roots. First, let's note the dates. It's 26th. Something weird happened this morning. I scheduled the meeting for a few minutes and I joined. No problem, Anika. So I scheduled the meeting post to be sent to Edmodo by 10 because I slept late. So I think I slept around 4 a.m. And I couldn't see it. So that's why most of you couldn't see the link on time. Sorry about that. I don't know what happened. I scheduled it to be for 10. Anyways, is Anika back? Okay, I'll just put this here. So again, today is 26th. It's a Wednesday, 26th. So like I said the last time, I'll show you what we did the last time. It's still symmetric properties of roots. Looks horrible, I know. Don't tell anyone. That's better. So our goal today is to use this symmetric properties. I'll show you what we did last time. Okay. Can you guys see my screen?
Yes, we can see your screen.
Okay. Question with given roads. This what we make sure. Yeah. So this was your last lesson. Now, I believe we all remember this. So our goal today is to use these properties, the square, the cube, and the difference, all right, to evaluate things like this. First of all, has anyone been able to attempt this question that I asked you to attempt? Anyone?
Mr. Daniel?
Yes.
I did it.
I don't know question 6 and 7. I tried the rest of them.
You tried.
I did 1 to 4, but from 5 onwards I couldn't do it.
All right. Okay. 1 to 4. That's not bad. So Alex, you did 6 and 7, or you don't know 6 and 7?
I don't know how to do 6 and 7.
Okay. Anyway, that's fine. Nice try. Anyone else tried? Well done for those of you that tried. Like I said, it is not like a compulsory work to do. It's just some attempt to maybe keep you busy if you wish. So let's go right to it. So basically, there are actually 2 ways we can apply the symmetric properties of roots. So we're only taking it 1 step at a time. The first is the one we're going to do today. The next is what we'll be doing next class, which will be on Friday. Now, so this is about using these properties, okay? These properties in 5, the property that we label 3 and 4, of course, in addition to what we have labeled in 1 and 2, okay? Our goal is to use these properties to evaluate these expressions without solving for alpha and beta separately. Can we get the value of alpha multiplied by beta square and alpha square multiplied by beta without actually getting what alpha is and what is beta? If, like we said last time, if alpha and beta are whole numbers, it is easier to work this out. Yeah? But if alpha happens to be a fraction, it becomes more complicated, especially in the case of question 5. Now, if alpha and beta happens to be in surd form, then even question 4 and question 6 becomes more complicated because now you have to expand a surd in a cubic form. Okay, so these properties from 1 to 5, basically, actually from 3 to 5, because 3 to 5 depends on 1 and 2. So I'll just say from 3 to 5. From 3 to 5 allows you to do this computation, allows you to work this out without first finding alpha and beta. That's one part of it. And that is all we're going to be doing for today. I will start specifically with this question. We'll add more to the questions. Maybe we'll take another equation entirely. Okay, remember alpha and beta are the root of this equation. So alpha and beta is about this. These problems will be about this equation, all right? For another equation, we'll be discussing what to do with the roots of that equation on its own. So you have to be careful. The other thing we'll be looking at on Friday is what happened, how do we use this to find the root of another equation? Take for example, if alpha and beta are the root of this equation, and maybe the equations are 1 and 2, just for example, you can be asked to find the equation whose roots are alpha plus alpha square and beta square. Alpha square and beta square would be 1 and 4, right? So without knowing what alpha and beta are, how can you find the root of the equation with the roots 1 and 4 without knowing what 1 and 2 are in the first instance? Do you guys hear me? Do you understand what I'm trying to say?
Not exactly.
Okay, so let's come to the board. Let's come to the board. It's for Friday. I'm just giving you heads up, which will make it sound better to you. So alpha, beta are the root of this. If we work it out, alpha is 1 and beta is 2, or it could be alpha is 2, beta is 1. On Friday, we'll be interested in finding the equation whose roots are alpha square and beta square. Now, if alpha and beta are the root of this equation, so instead of giving you, like last time, equation with given roots, if alpha is 1 and beta is 2, remember you will say x minus alpha, x minus beta, right? To find the equation. Now, we don't know this. This is unknown. The only thing we know is alpha and beta are the root of this equation, okay? Now, how can we use this information to find the equation with this root without first finding alpha and beta? Do you understand that? In this case, basically, you are actually finding equation with the root 1 and 4. So from this alone, you will be able to get x squared minus 5x plus 4 without actually finding alpha and beta. Does this make sense, guys?
Yeah.
So that's the second part of it. So the first part of it is just to work things out, to evaluate the roots, function in terms of the roots. The other part is to use those roots to form another equation that is related to those roots. And that will be for Friday. So, but for today, can I please get a response from everyone so I know that everyone is following? Do we understand? Just type in yes in the comments section, okay?
Yes, I understand.
Please, I just needed to know if everybody is following what I'm saying.
I don't get what we have. Do we have the equation?
Which part exactly are you talking about? I mentioned a lot of things. I mentioned what to do today, what to do on Friday. So which one are you saying exactly?
The part where you just erased. So did we have A and alpha and beta, or did we have the equation? What were we looking for? I couldn't.
Okay,
really
I'll just say you wait. I'll just say you wait, because I really don't get which parts exactly. Because for today, I said we'll be looking at how to evaluate some functions, and next time is when we form an equation, given an equation. Anyway, let's go to, you will understand very soon. If alpha and beta are the roots of, so from Friday, last question from last week, do we all have the question? So I'll send it to our WeChat. I think it's already on our WeChat, right? Let's see. Yes, it's on our WeChat. Okay, let's see. let's get right to it. Question 1. So I'll just say these are examples for today. Okay, so the goal here, just in summary, okay, without to be able to work out, or maybe is our usual learning objective anyway. So let's just call it what we usually call it. Okay. And maybe that could answer Elson's question. I should be able to work out actually. Expressions in alpha and beta without finding alpha and beta. That's the main thing. We want to work out the expression in terms of alpha and beta without finding alpha and beta. Okay, so we go right to it. So let's say question 1 says, if alpha and beta are the roots of 2x squared minus 7x minus 3 equals 0. Work out alpha plus beta. We'll start with this 2. Okay. Alpha plus beta is what? Hello?
Negative b over a.
Negative b over a. But before you say that, identify your a, b, and c to be on the safer side. Okay, so a is, so I just write it here. A is 2, b is negative 7, c is negative 3. And it will make sense to write alpha plus beta for any equation is negative b over a. So in this case, negative 7. For those of you that have tried this, I believe this is what you got. Oh no, over 2. You get 7 over 2. Talking to people, please. For those that tried it, did you get 7 over 2?
Yes.
All right. Alpha, beta, c over a, negative 3 over 2. Before I proceed, does everybody understand this?
Yes.
Yes.
Yeah.
All right. Good.
Yes.
Okay. Now, the C part of the question says, sometimes this A and B part may not be required in the question, but you should know that you have to find them first, all right? It may not be find alpha plus beta, find alpha beta first. The question could start from this third one, alpha beta squared, alpha squared beta. Okay, the question could start from here. So you make sure every time you express in terms of alpha plus beta and alpha beta, before you do anything, you must express in terms of this, which is why this must first be found. Is that clear? So we can factorize alpha beta, and then you will have beta plus alpha. Do you agree, everyone?
Yes.
Yes.
And your beta plus alpha is the same as alpha plus beta, isn't it? So remember, if this is beta minus alpha, is different. Okay, only plus can be written like that. So if I substitute alpha minus 3 over 2, then 7 over 2, I get minus 21 over 4. And that's it. No decimals, please. And you don't have to express that in this fraction. Okay? So D. So those of you that made attempts, you can always check with what you have done as I move on. D is alpha cube plus beta cube. How do we do this? You go back to our relation 4. Okay, I'm sure you can all see it on our WeChat. Can everybody access it in our notes? The relation labeled 4. Can you see that?
Yeah.
Okay.
Yeah.
Yes.
So that's what we need to state. We state that this is equal to alpha plus beta all cube minus 3 alpha beta into bracket alpha plus beta again. Okay, that's a relation. So again, it's in terms of alpha plus beta and alpha beta. That's all we care about. These are alpha plus beta. Okay, and this is our alpha beta. Okay. And this is our alpha beta. That's the target. Okay, that's what we want to do. So this will be alpha plus beta is 7 over 2. Alpha beta is negative 3 over 2. And this is 7 over 2. So what is 7 cubed? Because I need response in seconds.
343.
What?
343 over 8.
Please, can you not make me say I need response in seconds next time because we don't have time to waste. Stop waiting for people to respond. You respond, please. 343, am I right?
Yes, over 8.
Yes, over 8.
So minus times minus is plus. What is this product? 9 times 7 is 63. Is that correct?
63 over 4.
Over 4. So adding this fraction gives what?
471 over 8.
471 over 8. Is that correct? Someone is being noisy there. Someone's sibling is around, I guess. All right, so the next question, I think this is the one Alex is talking about. Alex, am I right?
Mr. Daniel, for the
Yes, sir.
answer for D, I got 469 over 8.
Uh-oh. Okay, guys, everybody verify.
I also got 469 over 8. I just checked on.
So did you get the two
Yeah, me too.
fractions? Yeah,
Yes, I
these
got the two fractions.
Correct. All right, so let's put in the calculator and check. Calculator is allowed. So I'm checking.
I got 469 as well. Mr.
It's
Daniel.
469. So whoever get 471, please check again. It's actually 469. Thank you, Justin. So please just lay back and be quiet. I didn't hear from Sisonia, Melody, Charlene, Anika. You guys haven't done this, or you don't know what we are doing, or you don't have a calculator to check, or it's just none of your business. So which of it? I'm expecting response from those that haven't said anything to tell me why they were quiet and watch us make this mistake.
My calculator was not with me just now.
Please, I don't want absolute silence, please. Thank you, Justin. So it's 469. I hope my 9 is cute enough. Anyway, OCD won't let me leave that alone. Anyway, so this is beta over alpha plus 1. What do you suggest we do first here? Anyone? Again, what is the goal? Can someone remind me the goal?
To have alpha beta or alpha plus beta.
Exactly, that's the goal. So just the first thing you could think of is combine it as a single fraction. That would be the LCM, yes?
Yes.
So the first part will be alpha times alpha plus 1. Then we have beta, beta plus 1. Does everybody get this?
Yes.
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 Who doesn't understand this? Say something. Elsin, say something now. Don't say something when I'm in step 11 and tell me you don't understand what we are doing. I'm talking to Elsin.
I understand.
Okay.
I understand.
All right, good. So this will be, so we open this bracket, alpha squared, alpha, beta squared, beta, and this also doesn't look like alpha and beta, alpha, beta, or alpha plus beta. So the bracket has to be opened as well. Alpha plus beta, alpha, beta, I mean, then beta, then alpha, then 1. Looks like denominator looks okay, right? But the numerator doesn't look okay. What do we do? Talk to me, please.
Factorize.
What? Giselle, or is that Denise?
I think collect like terms.
Collect like terms. Thank you, Elsin. Collect like terms. Not like anyway, but just regroup. Alpha squared, beta squared, then alpha plus beta. And this is alpha beta, alpha plus beta plus 1. So if you look at it, this is okay, this is okay, this is okay, but this is not okay. Am I right? So
Yes.
this that is not okay, what do we do?
We state the rule for the squared one.
What relation number is that?
I think it's
3.
like 3.
3. So we put in 3. Alpha square plus beta square is alpha plus beta all squared minus 2 alpha beta. And all you have to do is copy and paste this back. And everything all over alpha beta, alpha plus beta plus 1. Type in yes if you understand so far. Good. All right. So let's substitute the values. This is 7 over 2. This is 2, negative 3 over 2. This is 7 over 2. Negative 3 over 2. 7 over 2 plus 1. 49 over 4. Right? Plus 3 plus 7 over 2 divided by this. We can combine. What is this? Is that 3? Yes?
Yes.
Okay. So combine this. Use your calculator to combine that fraction. What do we have?
75/4 is what I got.
75/4. And we have divided by 3. So that's 75/4 times 1/3. Right? Which is 25/4. Alex, is that okay now?
Yes.
Any questions, please? Anyone? So, question 6 is 3. Alpha square beta cube plus 3 alpha cube beta square. What do we do? Anyone?
Factorize.
Factorize. I'm sure Justin isn't the only one in this classroom. So what is the common factor? Someone else. I don't want to hear from Justin or Kelly or Alex.
3.
I don't want to hear from
3 alpha
Alex.
squared beta squared.
Okay. 3 what?
3 alpha squared beta squared.
And in the brackets, we're going to be left with what?
Beta plus alpha.
Okay, so Elson is also excluded. Can I know what to do next? Anyone else? And time is running out, so please speak up. I'm fast.
State the third rule for alpha square and plus. I'm sorry, I wait.
What?
No. I think I did something wrong. Wait.
Okay. Yes, can I hear from someone? Yes, anyone?
Use the third one, the third rule, and
The third rule is alpha square plus, the third relation is alpha square plus
relation.
beta squared, right?
Yeah.
Why are we using this?
Substituted in.
Substitute in where?
Alpha squared and beta squared.
But I can't find this from here. It's not here. Or can you?
Oh, never mind. Sorry.
All right. I think Joey didn't get enough sleep. That's
Mr. Daniel,
Yes.
may I ask a question? This is all these A to E questions coming from the 10 questions last lesson?
Yes,
Yes, Alex.
Did I write something wrong?
There were only 7, not 10.
Oh, that
No.
should be minus.
Yeah, that's what I'm thinking.
Ah, that should be minus. Okay. I didn't get enough sleep. Thank you. Yes. All you have to do here is this. Can you see that?
Yes.
Then this is actually alpha minus beta, then with a -1. Do you agree?
Yes.
Yes.
So this -1 makes this -3. So I'm going to write -3 alpha beta all squared. Then you go to the last relation. The last relation is plus or minus the square root of alpha plus beta all squared minus 4 alpha beta. Okay, so now you can substitute. Everything is now in terms of alpha plus beta and alpha beta. So you have -3 multiplying, what is alpha beta? -3/2 all squared. Then multiplying plus or minus the square root of alpha plus beta, 7/2 all squared minus 4 minus 3/2. This makes sense?
Yes.
Yes.
So this is 9/4 plus or minus square root 49/4. There's no power here. So this is plus 6. What is 49/4 plus 6?
Is it
73 over
73?
Yeah, so 27/4 multiplying plus or minus square root of 73/4. So this is minus 27/4 multiplying plus or minus root 73 divided by 2. This is multiply. Okay, this is multiply. So this can now be into two parts. Minus 27/4 multiply root 73 over 2, or minus 27/4 multiplying negative root 73/4. This is multiply. So this will be finally minus 27 root 73 divided by 8, or plus 27 root 73 divided by 8. That's the best you can do. No decimals, no mixed number. Questions? Hello?
No, no questions.
I don't have any questions too.
Yeah, I heard from 3 people out of 18.
No question for me.
I'm fine.
Waiting for more comments. All right, no questions. So let's take the last part of the problem. The last is 7. That will be, is that G now? It says alpha squared minus beta squared. So what do we do with this? What do we do with that? Waiting, and I have 10 minutes, guys. Can anybody hear me, please?
Can we
Mr.
take
Daniel?
-1 out or something?
Alex, are you answering the question, or you have
Yeah,
a
I tried.
question?
Beta plus, alpha plus beta, bracket, alpha minus beta bracket. Is
Yeah,
that it?
is that what Justin also said?
No, I said something else.
Okay, so it should be difference of 2 squares. This is okay, and we have expression for this. So this is alpha plus beta, remaining alpha plus beta, and this is plus or minus the square root of alpha plus beta all squared minus 4 alpha beta. Is Anson in this classroom? Is Anson here today? No, okay. Does this make sense, everyone? So I need you to, maybe let's just substitute quickly. So this is going to be 7/2, then plus or minus square root of, no, actually times plus or minus. So you want to put the brackets, right? So this will be 7 over 2 squared minus 4 negative 3 over 2. So actually, I can multiply this sign. So the main sign will be plus or minus, all right? You can do that. You don't have to wait. You can do that. Plus or minus. So I can bring out the plus or minus sign. Like, for example, if this is plus, plus times plus is plus. If this is minus, plus times minus is minus. So I can as well just put it here. Does that make sense to everyone? So I can write it
Yes.
this
Yeah.
way. So it makes my writing even better. This is 6. So basically, this is what we have written in the previous one. So we're just doing almost the same thing. Plus or minus 7 over 2, then square root of 73 over 4. So which is plus or minus 7 over 2, root 73 over 2. So the two values will be what? 7 root 73. Yeah, talk to me, please.
Yes.
Yeah.
Over 4.
Over what?
4.
4 or
Negative 7. Root 73.
so those are the possible values of alpha squared minus beta squared. Okay. Questions, please. All right. Now, okay. In the last 5 minutes, I need you to attempt this and make it short. I'll write one more. So I'm trying to find a question. So you may start with one. Just pretend I've written the third one. So you can start with your solution. I'll write one more. So let's start. Quadratic. One. It's 59. Let's see. So let's make this the third one. All right. Who is done? Are we all working on it?
Yeah.
Okay.
Yes.
Yes.
Okay.
Mr. Daniel, I think I finished.
Okay.
I think,
Can you send me what you did privately?
okay.
I'm waiting, Alex.
Mr. Daniel, I think I finished too.
Yeah, could you send to me also, Justin? Alex,
Yeah,
very good. Alex, correct. Everything is correct. Detailed workings, perfect.
Thank you.
Please send to me privately if anyone has finished. For you, I just received yours. For you, I can't see A. I can see B, C. So your A begins with alpha. Oh, you, this is what I see. After the first step, the second step, where you identify your sum and product. So this is where your A should begin. Then you wrote alpha plus beta all squared minus 2 alpha beta. So the question is, what is this? What are you trying to do? In the B part, I could see alpha cube plus beta cube is equal to something, something, blah, blah, blah. So this makes sense. But what exactly is this? Can you hear me?
Yes.
So I expect you to tell me alpha square plus beta square before you write this, because you can, yes, we know this is equal to, then you substitute. This is equal to minus 2 squared minus 2 times. Yeah, we know that this is this because you already said it. But how did this come about? What are you trying to do? Here you told us this is equal to this before you substitute. So we know that this is equal to this. What exactly is equal to this? So if you do this for me, I don't think I'll give you all your points.
I wrote the question at next to A, which is the first line. Can you see it?
Oh, yeah, I see that now. However, that's not supposed to be your first line. What
Okay,
did
I
I
understand.
say in the previous, in my example? Before you can begin anything, this should be the first line, this and this, before you begin anything. In fact, your ABC should be your first line. That was why we did it here. Before you begin anything, that should be your first line. So please write exactly how it should be.
Okay, I'm sorry.
All right. Joey, I've seen your work. Okay. A lot of you are not on my WeChat, so I'm seeing your request. That's fine. So please add me up so you'll be able to submit work to me during lesson. Who is Vendetta, please? I need to be sure who I'm hiding. Is that Justin?
Yeah, that's Justin. Justin.
Your display picture gave you up and the name. Miss Kelly, seeing your work now. All right, because of time, because I need to leave now, feel free to send in what you have and watch out for my homework that will be uploaded later. All right, I'll do that in the next few hours after my meeting. I have a middle school meeting in the next 3 minutes. So just to be clear, the first thing I need you to do is to identify your ABC. B is -2 and C is +5. After you identify your ABC, I need you to get alpha plus beta and alpha beta, even if it's not part of the question, before you can begin A. This is the first thing you need to do. Alpha plus beta is minus B over A. You need to show minus B over A. Do not write alpha plus beta equals 2. Alpha beta equals 5. If you do this, I give you 0. Minus B over A, the minus 2 over 1, which is equal to 2. Alpha beta is C over A, which is 5 over 1, which is equal to 5. Don't be lazy. Show me the steps. Can Elsin and Mr. Ironman hear me? These are my two friends when it comes to writing short solutions.
Yes, yes.
Good.
Yes.
So alpha squared plus beta squared, and you recall. Okay, alpha plus beta all squared minus 2 alpha beta. I've gotten a lot of solutions. So Giselle, Rita, Sonia, Justin, thank you. And I've gotten 2 more requests now. Shirley, I can see your request. Added, who's there? Anika and Melody. So I'm adding everybody. Please send in what you have done. I will have a look. Even though we are doing the correction, doesn't matter. Still send in what you have. Melody. Okay, I think I've added everybody that sent me a request. Denise, Melody, Sonia, Anika. All right. So then we substitute. Yeah. So we substitute what we have. This is going to be 2 squared minus 2 times 5. Okay, that's going to be 4 minus 10, which is -6. And this is what a lot of you have done. Alpha cube plus beta cube will be alpha plus beta, all cube minus 3 alpha beta into alpha plus beta. So this is going to be 2 cube. I'm not using a bracket here because it's not negative. Okay, minus 3 times 2, no, times 5, right?
Yes.
Then times 2. Oh my God, I'm late for my meeting. 8 minus what? 30. Yes? Minus 22. And the last one might be, maybe, don't be confused. It's not a big deal also. Okay, so you want to make sure they have the same denominator. Remember, you multiply by beta, beta, alpha, alpha. So this is going to be 3 beta divided by alpha beta. This is going to be 3 alpha divided by alpha beta. So basically it's 3 beta plus 3 alpha over alpha beta. So you can factorize 3 and rearrange. So I have this. Okay. And that is 3 times 2 divided by 5, which is 6 over 5. So that is what I expect you to have. Most importantly, these 4 steps, very important. Very important. Before you write A. Okay, for any question, identify your ABC, find the alpha plus beta, find alpha beta before you begin the questions. Any questions, please?
No.
No, all right. I'll see you guys on Friday. Watch out for my homework very soon. I need to get out of this class and log on to the middle school meeting. Bye, everyone.
Bye. Have fun.
Bye. Thank you.
Bye.